Hello, I am Rafał Pocztarski and I will talk today about what is Deno. I will not go very deeply into its internals because other talks will be about it, but I will just try to explain what is it and what we can do with it. So basically it is a new runtime for modern JavaScript and TypeScript backends for the 20s. And maybe a little bit about me. It's you might know me from Stack Overflow. I always put my avatar on my slides because some people who are active on Stack Overflow recognize it more than myself. Okay, that's enough about me, and let's go to the presentation. If you want to follow the slides, because there will be some links, then you can go to this URL, but it will also be available at the end, so you don't have to. But some people like to follow the presentation, so that's it. What is Deno? I've already done some presentations about Deno, but today, as there will be more presentations, I am going to focus on some things, so I am not going to talk about everything. So I will not talk about what it is built with and what JavaScript runtime it is, but basically what we can do with it today. And when it was created by Ryan Dahl in 2018, so this is a very fresh project, and it works on Linux, Mac, and Windows. This is a rough timeline of some of the most important things related to Deno. So Node was in 2009, TypeScript was created in 2012. In 2015, there was a project called TS Node that allows us to run TypeScript programs in Node directly without any explicit transpilation step. And Deno in 2018. And as you can see, this is something happens exactly every 3 years. So in 2029, there will be some other breakthrough, but we are not sure about it yet. How to get Deno? There is a website, deno.land. If you want to download it, it's pretty straightforward. So if anyone wants to try it right now or after the presentation, it's quite easy. The installation is for people who are not afraid to run random scripts downloaded from the internet and pipe it to their shells, which I wouldn't do, but this is an official way to install Deno. But what those scripts do is basically they scrape the GitHub website with Deno releases, so you can just go to this URL and get the file for your architecture. There are binaries for Windows, Mac, and Linux, and all you have to do is just unzip it. It's not even a tarball because those Deno is distributed as single binaries, so those are just files with GZ extension, and you just use the gunzip command to get the binary, make it executable, and put it anywhere where you can put executables. So the installation is easy. There is single file, not just a tree like with Node or other runtimes. And now how to use it. If you have Deno, then you just write a TypeScript file. I put explicit type annotation here to make sure that this is not valid JavaScript, and you just run deno run script.ts. So you just run directly TypeScript without any transpilation to JavaScript, or you can use JavaScript in the first place if you prefer. So both languages are supported out of the box. Running such a file for the first time shows a message that it's being compiled, and for the second time it's not compiled again. So it's cached and it starts quicker than for the first time. And this is the compilation from TypeScript to JavaScript, and it's actually quite fast because also the TypeScript compiler is embedded in Deno as a V8 snapshot, so there is no problem of compiling the compiler first before compiling your own code, because this is something that makes the usual TypeScript compiler or TS Node start with some delay. Caching I already said something about caching, and it's useful to know where the caches are, because sometimes if something goes wrong and you want to, or you want to test it to, for example, like I wanted to show the messages that are displayed when there is when the compiled version is not cached yet, then I had to remove the caches. So by default on Mac, it's in library caches Deno, and you can also use the Deno_dir environment variable to use other directory, like for example something from the local directory. And last time I checked, just putting a dot there didn't work, so you had to put a full path. So the pwd command is for that. The first one of the first questions actually on Stack Overflow that I saw about Deno is how does it compare to TS Node, because people were saying, okay, we already have an option to run directly TypeScript without explicit transpilation, so why a new project? So I wrote an answer there. If you are interested, you can take a look. And basically my very simple test showed that it was like 32 times faster on startup than TS Node. So it was a few months ago, so I guess that is even faster right now. And it was one of the very first version of Deno. It was already very fast, and also in this answer I explained how to create a library in TypeScript and put it on npm if we are using Node, and how does it compare to publishing a library in Deno. And in Deno it's much easier, but we'll soon see it in details. What's interesting is that we can run remote scripts. This is one of the scripts that I prepared for this presentation, and if you have Deno, you can just execute it. And the first thing that should come to your mind should be that is it safe to run some random program from the internet that you are not that you don't even see what's inside, and the answer is that yes, but we will go to it in a minute. But first I will show you what is displayed when you run this command. First it will download the main script from the URL from the command line, then it's compiled, and then a dependency that it happens to be there is downloaded also. But for the second execution, it just uses the cached version of the file, so it's much faster. So even you don't even need to install the tools that you need to use, and this is actually pretty similar to just using websites. You are not downloading a website first and then execute it. You just execute something from a URL, and you also are pretty sure that unless there is some exploit in the browser, then it is safe to execute random code from the internet, because it's sandboxed by the browsers. It doesn't have any access to any data that it shouldn't have to. And so the security in Deno is actually enforced by a way that no network and file system access by default. The write access is strike through, because first the read access was allowed by default, but it had some consequences that if the program could read any file on the file system, then it could send the data somewhere else, even without explicit network access, but using, for example, dynamic imports. So it had to be restricted even further. So currently no network and file system access by default. So the program that you would execute, like the example from my website, would not have any access to your file system, to the network. It wouldn't be able to do any network requests or even use high resolution type measurement. I'm not sure if it's really a security risk, but I guess that it is. So this is one of the exceptions that we usually don't think about when the other things are pretty obvious. But and also it's important that the environment variables are also restricted, so it's even safe to to execute the commands and be sure that they will not read any environment variables that may be set to some tokens or something like that. Examples of running Deno scripts is like, for example, Deno run allow read. You can specify an exact file, and this script will only have read access to a single file on the file system and nothing else. The second example is it would be able to write to the temp directory but not do anything outside it, and in fact it would even not be able to read from this directory. So maybe it's not a very good example, but sometimes, you know, like writing log files, there are things that is more important to write than read. The allow net access here is gives access to any network request, but it also can be restricted, which we will show, we'll see in other examples. So one of the things that is unique in Deno is that we import directly from URLs. So we don't need anything like npm or node modules or something that we can be used from other runtimes. We just use a URL with a TypeScript file to import directly from it, and Deno we will know what to do. It will download it once and not do it again. For the first time we see that the file itself is being compiled, then the dependency is downloaded, and for the second run it's all cached and no other network requests are done. And we can actually, even using the local caches, we can even prepare it beforehand so that we can run programs without any internet access, because this is something that people are often worried that if everything is downloaded from URLs, then what if I would like to run some program on an airplane or something that or when I don't have an internet access. But we can actually download it beforehand and cache it and then run it afterwards. We can also run remote scripts, as I showed in the previous example, and we also have dynamic imports and top-level await. This is something pretty useful, and I don't know if any one of you is familiar with dynamic imports, but it needs to have await, and the top-level await is not something that was in Deno from the beginning. I think in Node it's still not there. Because it would break the module system that needs to be synchronous in returning the exported objects. Running script with dynamic imports shows us something that Deno does, that it shows us a prompt to that the program wants to make a request to the network. With dynamic imports, it's possible to compute that, because with normal imports, we can only use string literals. We cannot use any variable and change it to use some dynamically change the URL. But with dynamic imports, we can. So it's important to control which request we are doing, because in principle, a program could, for example, try to import 1 million files from some machine that it would do just to create a DDoS attack for it or something like that. So it's important to even restrict from what we can dynamically import. And if we run just Deno run and the script name, then when the program wants to download the file, then the Deno interpreter asks us if it's okay if we want to grant the privilege to do it. So and we can tell it to allow to download from this place always, once, deny once, or deny always. And if we say yes, then it continues execution. But we can also in the command line we can use allow net and enter, for example, a domain name, so that it will not ask us for privilege to download from this place. And this is an example that is like pretty obvious for a runtime like this, is how to create a HTTP server. So this is quite different if you are familiar with Node, where everything is based on callbacks. Here we are using a for await loop. So basically what we are doing here, and currently I said that we have a top-level await, but it seems that top-level for await doesn't work. So So maybe I don't know if it's on the way or this is something completely different, but I had to wrap it with a function, with an async function, and execute it immediately. So what's important is inside of that async function, we see that we import the serve comment from the standard library of modules. And what's also visible is that we are using a text encoder. This is something from native from the language, from JavaScript, and because we are using typed arrays for buffers instead of using custom solutions like in Node.js, where the typed arrays were not available when it was created, so the buffers had to be created for Node. But here Deno is using the standard web way of using binary buffers. And this is the serve function. This is a very low-level API, so it doesn't even accept strings. It needs, as a body, it needs to have a typed array, so that's why we need to use the encoder encode method. But what's interesting here is that when we create a server with the serve command, then the server is actually it's an async generator, so we can use the for await loop to serve the requests. And as you can see, there is no other function here. This is a single function, the top level async function, but we are not creating a new function for every request. This is just an asynchronous loop, and inside of it we can just do something, and then request respond is the command to send a response with a body, a property that needs to be a typed array. That's why it is encoded here. Running this server also asks us a prompt if we allow it to listen on the network access, and we can deny, we can allow, but then if we want to avoid those prompts, then we can use just allow net, and the port number will tell Deno that this program is allowed to listen on this port number, but if it would try to listen on another port number, then it would still need our permission. So we can be sure that all this program can do is it cannot read any files, it cannot write any files, it cannot use high resolution time from the system, and it only can listen on this single port. If it would like to listen on some other port, and then it wouldn't be able to without our explicit permission. And here is one example that I wrote how to serve files with this simple API. This is a very simple web server. It doesn't use any framework or anything like this. It just uses the standard library. This is just the for await loop from the other example, so it needs to have some boilerplate of importing the serve and running the server, but just to make it more visible, this is the loop from the previous example is just bigger because we are trying to actually read some files. So what we can see here is that Deno has a built-in read file method, and the await here shows that it returns a promise, and all of the built-in Node.js, if you are familiar, functions for the FS module take callbacks, and there are some other modules to return promises, but here everything is using promises from the start. And it plays well with the await keyword and with other modern ways to manage asynchronous control flow. So here this is very simple. We are just putting this in a try catch, because this is also something nice about await, that it works in try catch blocks, and we are returning 404 if something is wrong, which is actually not only when the file is not there, but also if it would have no permissions. but sometimes this is desirable to, for example, GitHub doesn't show you that if you don't have permission to some repo, then it doesn't show you that you don't have permissions, but that it doesn't exist. I think there is some question.
And how is the Deno global different from importing from the standard library?
Because those are there are like three main. It will be shown in other slides. The Deno is without importing anything. It's built in. This is the very basic internal Deno API, and there is some standard library provided that needs to be imported. So the Deno is always there. We don't need to import it. So here the it's like the text encoder and other built-in objects or classes, and here there is no here is the serve needs to be the URL is from the STD is the STD, and the version of the Deno interpreter means that this is the standard library that is compatible with that version of Deno. But the Deno is there always without any imports. So here is very simple. We are just reading files. If there is any exception, then we give 404, and if the method is not get, then we return method not allowed. And okay, it's good that you asked, because I thought that no one will notice. The URL is in HTTP is actually just a slash and a path without without a host name or port or anything or the protocol. So if you go to, for example, here it would be localhost port 8000 / abc.txt, then the request URL will be / abc.txt. So the dot means that it's in the in the current directory. And it seems that it's not very secure, because if someone puts double dot in the other parts of the path, then we would have path traversal vulnerability. And actually, I actually wanted to do it for this presentation, but it seems that Deno is smart enough to remove those double dots for me, so I couldn't do it. But here I don't have to really think about it, and this is one of the points of this slide, because when I run the HTTP file server, I can tell it which directory I want it to be able to read. So even if it was possible to trick my script to try to open some file from outside of this directory, which the Deno would still get an error, because we use the no prompt argument, and it means that if there is no permission, it doesn't ask me for it, but it just throws an exception. So so this is using the Deno permissions to not worry about something that I would need to sanitize the input myself, because even if I do something wrong, then Deno itself would not allow me to open any files outside of this directory. And in this example, we would only be able to use HTTP localhost 8000 /dir /something, because otherwise every other file, even if it exists, it would give 404 because it would throw an exception on the read file, and we said that 404 is just a catch-all exception for any problem opening files, no matter if it's missing or has no permissions or something like that. So this is showing that it actually can make us more relaxed about not having to worry so much about sanitizing inputs like this, because it would still not be able to open anything outside of the directory that it was explicitly allowed to open. Another thing that I wanted to talk briefly about is that I don't know if anyone of you is using TS Essentials project, and this is this is a collection of TypeScript types that are very useful to compose your own types, and it's written just for mainly for Node, and it's a normal npm library. But I noticed that we could just import directly from the URL from GitHub, and it works in Deno. So I'm not sure if I thought that maybe Chris Catcher would be here today, but he is not, and I'm not sure if he is aware that his library is already working with Deno. I would have to tell him it, because I don't know if he's aware of that. And this is something that we can use some interesting, for example, the merge type. It takes two types and merge them in a way that the second type overrides the first one. So normally that would be an error, because B in type A should be a string, but since it's merged with the type B, then it's okay that it's a number. And other example that I put here is mark required. So when you have a type where certain fields are optional, but you want to create the same type but with certain type required, then you can use mark required type using the name of the field that you want to be required, and the first one would be okay, but the second one will show a nice error that it's basically that it's required. So those are types that are basically used in complex Node applications written in TypeScript, but it works very well in Deno already, so we can use it, and we don't have to worry that Deno is not compatible with npm, because we can just download that script from the internet. We don't have to install it anywhere, and it works very well. Of course, not everything will work, because Deno doesn't support the API of Node, but here this is just basic TypeScript, so it works nice. Also, since Piotr said that he will not touch any runtime that doesn't support WebAssembly, then I prepared an example, especially for you, about WebAssembly in Deno. So, for example, we want to write a factorial in C, because we don't trust JavaScript or TypeScript to be fast enough to calculate factorials for us. So, if we have a C program, as you can see, the types show that it's C, because otherwise it's pretty similar to JavaScript. We can compile it with mscripten, or there is, I don't know if any one of you is aware, but there is Wasm Fiddle. It's very nice thing that you can just open a website. It's like JS Fiddle or JS Bean or CodePen, something like this, but you can create scripts in C, C++, or some other languages, and it compiles it to WebAssembly and runs it in the browser. So if we can also download the binaries there, so it's easier than to install all of the tools ourselves. And here is what we can do if we have a WASM file compiled, for example, in the Wasm Fiddle from this function. Then we can access it like this in Deno. So we just use Deno read file to get a buffer with that file. This is an argument to a constructor of WebAssembly module, and then instantiating, then basically making a new instance, WebAssembly instance from that module, because we could have several instances. It have exports and factorial, because that was the name, and we just use it as just like a JavaScript function, and it works very well. And we can see that it even asks us for a permission to open this file, but if we allow it on the command line, that it doesn't even need to. So WebAssembly works perfectly well in Deno already, and there are some resources if you would like to see, because actually this assembly script is an interesting project. It's something like TypeScript, but with WebAssembly types. And it's compiled directly to WebAssembly and works pretty fast. There's other projects similar to that. And here are some of the languages that can be compiled to WebAssembly. I don't know if every language that you would like to use, Piotr, are there, but maybe some other are on the way. So also there is something that JSON here is using very frequently, so he asked me to investigate if Deno supports bind call and apply very well. So indeed it does. And here are some of the examples that I used to. I encourage you to maybe not right now, but maybe later on the slides to see if you can follow everything, how it works, and for example, what is a result of calling apply on a result of bind, and what will be the result of something like this, because it might not be very obvious. And here, actually, in the Warsaw.js Slack channel, we tried to do basically a bind without using the built-in bind in JavaScript. So this is what I came up with, and I don't know. So far, no one has simplified this. So, but maybe if some of you can simplify it a little bit, then I will be grateful, because it's quite complicated. But what it does is does basically what a bind does normally. But since there was some discussion that bind should not be used because it's very old school, then we can just use this if we prefer. Okay, so this is what I already talked about in the beginning. The built-in API is basically everything that is on Deno, on the built-in Deno object, and this is explained under this URL. And basically, this is generated TypeScript, generated documentation from the TypeScript types that are there. And it's funny how many you can how many informations you can get just reading the types of functions and methods, because sometimes it's quite obvious how to use it when you exactly know that, I don't know, if it returns a promise of something that has certain fields, it's easy to work with it. So this is a quite extensive documentation of everything that is built into Deno. This is a list of standard modules, and those are guaranteed to be compatible with all versions of Deno, and they are versioned with the same version numbers as the Deno itself. And here is the URL with the list of third-party modules, where everyone can add something, like Bartek did the Postgres database driver for Deno, and there are not that many modules yet. So if anyone is interested, then I guess this is a good place to start. But I will not talk about it, because there are other talks today that are about it. But this is where you can find what you can use today. Those are some libraries, third-party libraries that you can use right now.
The package name is letter, is maybe
I think that it can be missing there, but it is quite essential. So I guess that we should see a pull request today. And okay. So this is something that I was talking about when I first got interested in Deno last year, when it was first announced. This is the reasons why I think that Deno will get traction, and those are not related to technical advantages of Deno, nothing about security, nothing about the convenience of using imports, of using TypeScript, but those are some interesting things about it. That first of all, it's created by Ryan Dahl, the creator of Node.js, and he is already known for creating runtimes that are hugely popular. So this is already something that if it would be created by someone else, I think it would not get so much publicity so early. Another thing is that it uses V8, so an engine, JavaScript engine by Google. So Google will have a good incentive to promote it as something that uses their technology. It uses TypeScript language by Microsoft, so also Microsoft has some stake in it, and it uses a Rust language by Mozilla. So having Mozilla, Microsoft, Google, and the name of Ryan Dahl in one single project, it is like it's sure that a lot of conferences will be Deno will be on topic on a lot of different conferences created by huge companies. So this is something to, I think it's also interesting to look at, because obviously we would like to learn technology that has some future and has a good chance of getting popular pretty soon. So I think those are some of the reasons. But the advantages, the technical advantages, is that I already talked about some of those. Is easy installation, easy development, because those are not the same things, but also the installation is very easy. So for example, it's very nice to have Deno in a CI pipeline, because you just download a single binary and run some Deno code without even, or you don't even have to download the Deno program, the script itself, because you can run it from the from a URL. So it's quite easy to add it to some existing tools. Easy development, because there is no need for installing everything. You just use a single file, especially when you are doing libraries. If you would follow my answer on Stack Overflow about creating a TypeScript library for NPM, then it's not that easy to do it. And for Deno, you just create a TypeScript file, publish it on your web server, and it's already there, or on GitHub or anywhere else. You don't need to build it, you don't need to package it, publish it. It's just a single file on the internet. The security by default, it's something very important for me. And also the fine-grained privileges, because if it was secure by default, if there was switch to just give access to everything or nothing, then it would not be that secure, because most of the people would run it with every privilege already granted. But here we can, as we've seen, very finely specify what it should be allowed to do. TypeScript support out of the box, this is very nice, because if any one of you was trying not only to create a project in TypeScript, because this is not so hard, but to publish a library written in TypeScript, this is even more complicated. This is very nice. Modern language features is, for example, like those typed arrays. This is an advantage of being a young project, so it can already use everything that is supported by the runtime. So Node did not have this advantage of being able to use typed arrays or imports or async await or something like this for their built-in API, and Deno already has that option and uses it extensively. So following web standards, because everything that can be done in a web way, especially like on the front end, it is already been done. Then Deno tries to use the same technique, even to the point of using window as a name for the global object, which some of the people were opposed to, because they said that there is no window here. But it's not the point. That global this with the strange capitalization is not that nice, and it works also, but the window is something that we are used to. So for example, we can create a Deno script that starts with window.onload and equals to some function that will be loaded on the startup.
So what function window.open?
I'm not sure. I'm not sure. I would have to try it. I don't know. I don't know if anyone else maybe you know it. I don't know if it is there, but I would guess that maybe it starts another. No, I don't think it would start another script, but that's a good question. I think we will have to investigate it afterwards. And the last thing that I enumerated here is the modern async await based API, because since it's already there, it works very well. For me, the best advantage of using async await is that the exception handling, that we don't have to use like two types of competing exception handling like we have in Node. So we have try catch for the synchronous errors and callbacks or catch methods on promises for the asynchronous errors, and we have to use both of those because, for example, JSON parse or JSON stringify can throw an exception, and pretty much no one is checking it. But here, if we have a single try catch that uses that can catch both synchronous and asynchronous errors, this is very, very useful. Here are some of the recommended talks that I listed here. Most of them are by Ryan Dahl. First, I think it's still nice to see the original presentation of Node.js because it can show us how little time have passed. It's just 10 years ago, and I remember when I've seen the original presentation, people were reacting like it was something completely crazy. It's a crazy idea, this Node.js, it will never work, and JavaScript on the back end. It was like, well, it was completely crazy. And using single-threaded servers, people were complaining a lot, and I think it's nice to compare those presentations to see how it all changed. There is a history of Node.js, but it's just like 2 years after it was created, so it's not very up to date, but it's also a very good presentation. And then there is a presentation 10 things I regret about Node.js by Ryan Dahl from last year, and this is actually a presentation when he was talking about problems that he already sees in Node.js, like npm, the node modules, all of the dependency hell that is caused by it, and that probably we should start another runtime. It doesn't have to be compatible with Node.js, but it's a nice idea to start from basically what he would change if he was starting Node once again. And then there is a Deno, a new server-side runtime by Ryan Dahl. It's when it was already decided that it's going to be created. I think back then it was to be written in Go and no Rust, but those are just like implementation details. I didn't want to talk about it right now. I focused on how to use it and what we can do with Deno right now. And for most of the people, if the abstraction is good, then we shouldn't even know by using the JavaScript code what implementation language is underneath. Like we don't need to know about C++ in Node, and but this is something that we will have on other presentations tonight, so I will not talk about it. Some documentation. Those are some links, some random links from most of the documentation, and also the TypeScript language. It's important to know TypeScript well for using Deno. Some resources. The main website is Denoland. There's Deno News where there are a lot of interesting news, so and I encourage you to follow it. Deno Warsaw and Deno Poland, those are not very active websites yet, but they will be soon, so it's nice to know about them. And a summary. So Deno is a JavaScript TypeScript runtime. It's a standalone executable. It has no dependencies, so I didn't talk about it before. You don't need to install anything else to be able to install Deno. So for example, if you like to install Node from the sources, then you need some certain tooling. Actually, if you would like to compile Node Deno, then you would also have a lot of tools. But some runtimes need certain libraries, like for Unicode, there are some dependencies sometimes for runtimes. This is by design a single executable that doesn't depend on any library on the system. It can import modules from URLs, support dynamic imports, supports top-level await, but without for await. I will need to investigate it maybe today, because it didn't work for the presentation. I didn't have time to see why, but it's interesting, and it provides a restricted sandbox to run your code safely without worrying that it will break your computer, or even without worrying that it will DDoS someone else, because if you run a program like, for example, a linter, then it doesn't need to connect to the internet at all. So a program like a linter just needs read access to a certain directory and nothing else. And we don't need to worry that maybe the author of the linter got hacked and someone has put some Trojan horse in the in his code, because it would just throw an exception if it wanted to do something that it was not allowed to do. Later tonight we will have another very interesting presentation, so I am telling about it because we will soon go to the questions. So if you have any questions that are related to those talks, then maybe don't ask me about it. If you have any questions about using Deno, then I encourage you to ask questions to me. But if you have any questions about developing with Deno or about Deno internals, then there will be other talks specifically devoted to those topics. So if you have any questions, then this is the time for them.
Yeah, I have two questions. At the beginning, you mentioned that if Deno downloads one file, on the second term, Deno doesn't make a request.
Yeah.
So what happened when the file on the server was changed?
I think that it. I'm not exactly sure if it checks the headers, if it's for the caching, but I think it doesn't. I think it just is based on the URL, and also I think that it ignores the query string if there is, which was strange when I tested it today. But I'm not sure if it maybe tested the. If it made maybe a head request for something and compared checksum to see if it's the same that was already downloaded. But basically what's the main idea to do is to use to use the version number in the URL. So for example, like it was in the std import, like here. So that the Denoland has, it's a service that if the Denoland std is for the standard modules, and if it would be x here / some other name, then it would be for the third-party modules. And this is a redirection service that would actually this will redirect. It doesn't serve it directly. It redirects to GitHub for a file tagged with this version number. And also it's, I think what's interesting is that instead of version number, instead of a simple tag like this, you can use also a commit hash. So that way you can be sure that you are downloading only the version from GitHub that has that hash, because you cannot store in Git, a changed file with the same commit. So basically, I think that it will not. Yeah, I think that it will currently cache forever. You can certainly you can remove the cache, like I showed on some of the examples. I'm not sure if dash reload. Yeah.
Okay, so the second question is about that slide. On the fourth line, you have called serve function, yes?
You mean?
You should ignore empty line.
Okay. Yeah, the serve function. Okay.
Yeah, and after that you run console log with information that server was started. I
know what you are asking. I am not sure if the server is already listening here. I think it should be, but no. But actually, the serve function returns a server instance. So await would be, it could work, but it would not be doing anything. I'm not sure if this needs to be. Yeah, yes. It returns an object immediately that is that can be iterated later, and here this await will wait for the first request to come in, and it will not come in before actually it is already listening, and maybe it should be some other place for me to put this listening. Because in the example on the Denoland website, this was not in the async function. here up to without console log was outside in the outer scope, but then there was what I said, the window onload handler, and the console log was inside of the function, async function that was in the window onload. But I wasn't able to find information if it's really waits for the ports to be listened on, or just because when I said, yeah.
Something and you're already announcing on the interface, and then you asynchronously wait for connections and request connect.
Yeah, because when I've seen the issue when Ryan Dahl was writing about the window onload, then he was like wanted to avoid this boilerplate of self-invoking functions basically, but I don't think that it was really waiting for ports to being open. This is the await in the for await loop. Yeah. I don't know if there are maybe any other questions. Thank you.
Let's switch.